So we can use an arrow diagram to represent domain, codomain, or range. Yes, an arrow diagram is a diagram. So arrow diagram. This is a diagram. This is a diagram that is used to represent domain, or you can just say to represent function. There is function. To represent function. Okay. So, and you know, domain, codomain, range are under function. Yes, they are under function. So, let's say we have I want to represent them now using an arrow diagram. So this is an example of an arrow diagram. I have A, B, C. Okay, I have E, F, G, H. Okay, you can see. So I have this A pair to H, B pair to E, and C pair to F. Okay, this is an arrow diagram. It's an arrow diagram where we have where this one is our domain. Domain is at the left hand side, or you can see we have the codomain CD is at the right hand side. So where the arrow is pointing to is the codomain. So now the codomain is the domain as A, B, and C as its element. It has A, B, and C as its element. While the codomain, this is domain, as A, B, and C as element, while codomain as E, F, G, and H as its element. So, by the range I told you is the verb is able to pair with the domain. So the range is just range. The element is E, F, and H. E, F, and H. So that is using an arrow diagram to represent the function. That's how to use an arrow diagram to represent function. So you can also use values. So that you will not just say the alphabet or variables that we can use. We can also use values. Look at this. We have a 1, 2, 3, 4. We have a 5, 6, 7, 8. So look at it. We have something like this. Okay. So you can see that the domain here is 1, 2, 3, and 4. Yeah, the domain is 1, 2, 3, and 4. So let me put the domain. Let me put the codomain. So 1, 2, 3, and 4. While the codomain is 5, 6, 7, 8. So and also the range is also 5, 6, 7, 8. So here the codomain and the range are equal. The codomain and the range are equal. So in this kind of situation, I'll be telling you what it is as we progress. So that's how to look for. That's how to use arrow diagram to represent the function. So, but as an arrow diagram that represents function, while there are some, as we use equation the other time, there are some arrow diagram that represent a function, while there are some arrow diagram that does not represent a function. So, the arrow diagram that does not represent a function is the R1. It not, so sorry, it will have values or elements at the domain side that is not able to pair with the codomain. Yes, that's unable to pair with the codomain. So this kind of arrow diagram, you have a 1, 2, 3, you have a 4, 5, 4, 5, 4, 5. So we have like this, So 3 that is here make this function, this arrow diagram, not an arrow diagram. So we just say the arrow diagram above, not an arrow diagram. Because there's a value at the codomain side. That's unable to pair. That's unable to produce an image. So we can also have another situation. Number two. If there is no bedding, so bedding is showing sign where in the diagram. So there must be an arrow. Yes, there will be an arrow. If there is no arrow, then it says not a function. So we have a 1, 2, 3, 4. We have a 5, 6, 7, 8. So look at this. Or some may show arrow. So this showing an arrow is called a bedding. So some may show arrow and some may not show. So in that situation, you see it's not, the arrow diagram does not represent the function. You see the arrow diagram does not represent the function. Okay? So that's just it. So an arrow diagram must be bedded. Yes, it must be bedded. If it's bedded, you say it's an arrow diagram. If it's not bedded, it's not an arrow diagram. Also, there must not be any value at the all the values at the domain must be able to produce image. So although if we can have some values at the codomain that is unable to pair, yeah, can have some value like this arrow diagram. This arrow diagram is, and it represents arrow diagram. This one, 1, 2, 3, 4. You have like 5, 6, 7, 8, 9. Look at this. So you see that 8 is free here, but we must not have something like that at the domain side. So we can have it at the codomain side. So that is just what we can easily say concerning arrow diagram that represent function and those that do not represent function. So that is just it. So we can have types of function. Yes, types of function. So types of function. We have types function. We have what we call one-on-one or one-to-one. One-to-one function. Or we say one-one function. One-to-one function. We can also have onto function. Onto function. Onto function. We have into function. Into function. We have a constant function. Constant function. We have constant function. We have the fifth one, which is identity function. So I'll be explaining them one after the other. Identity function. So one function, onto function, into function, constant function, identity function. So onto one function. One function is a type of function. It's a type of function in which one function is a type of function. Type of function in which it's a type of function in which a domain is able to have its own image. So one function is a type of function in which a domain is able to have its own image. It's able to pair with one image. It's able to pair with one image. So that is one function. That is one function. For example, we can have this using an arrow diagram. Using an arrow diagram, we have 1, 2, 3, 4, 5, 6. So look at this. We're able to see that this one pair with this one pair with this one pair with this. Or we can have in this situation. We can have in this situation 1, 2, 3, 4, 5, 6. So we have this. We have this. We have this. So even if it cross each other, provided it's able to form to have its own image. Everybody with its own image. So we can see this in sport. Yeah, you can see this in sport whereby you can see it in sport whereby what's the name? The opponent, that they mark each other. You just see that number 7 of this team mark number 7 of this team, number 2 of this team mark number 2 of this team, and so on and so forth. So in that kind of situation, we can say we are having one function. So a situation whereby what's the name? One person in the other team, or one of the footballer, is marking 2 persons, then that means that is even not a function. It's not even a function. So when we have two of them marking 1, you can see. So that is a function. You can have 2 people marking 1 person. It's a function because there are sometimes that there may be a reduction due to red card. So you can see the application of function. Yes, you can see the application. So we will see it in sport. We see it in every aspect of life. Every aspect. So just see that. sometimes even during apprenticeship or even in the academic sector, you see that someone who is a leader will have maybe somebody who is following an aide. Yes, we have an aide. So this person is doing this. Also, we have each person who can have his own driver. It's just that we have plenty cars. Then you see some different drivers driving it. So each by the time they want to move on, we just leave. They just each driver will just drive his car. So that's what we call 1-1. So that's it. So we can also have an onto function. Okay, that's so that we can get the true picture of 1-1. That's this kind of example is not a 1-1 function. This kind of example is not a 1-1 function. Okay, like the one I explained when you have when a red card. When a red card is issued to one team. So look at, we have a 1, 2, 3. We have a 4, 5, 6. So we see that okay, let me 4, 5, 6, 7. So this produces this. This produces this. Then this. So that you can get into picture of 1-1. I'm still on 1-1. I'm not starting the thing there. 1, 2. So 1-1. So you see this one, this produces this. We have a 2. 2 also produces 4. We have a 3. Then we have a 5. So you can see this 1 and 2 was able to have an image. Yes, this 1 and 2 was able to have image 4 as an image. Why didn't have a so this kind of situation is not a 1-1 function. It's not a 1-1 function is that these two should be able to have its own image. Yeah, should be able to have its own image. So when we have something like that, it's a function, but not a 1-1 function. Okay, so apart from 1-1 function, we have an onto function. You see on the board, we have onto function. Onto function. This is a type of function. In which the image equals the image is not equal with the codomain. The image is not equal. The image is not equal with the codomain. The image is not equal. So that is usually left over. There are some value that is unable to appear here at the codomain side. So when we have something like that, we think we're having onto function. Look at it. You can use this arrow diagram. I like using an arrow diagram to represent it so that the picture can be more clear. So we have a 1, 2, 3, 4. We have a 5, 6, 7, 8, 9. So there are ways of solving questions that to take it back to arrow diagram, but I'm just using it to explain it. So that when you solve question and just see it, you just okay, this is an arrow diagram, and you can easily tell us the kind of function it is. So let's assume I have a 1 to 7, I have a 2 to 5, I have a 3 to 6, I have a 4 to 8. So 9 is free. 9 is free. So this kind of situation we say is what? Onto function. Onto function. So onto function. So onto function. Onto function. So we can also have unto. We can have unto. Unto function is when the number of codomains. Unto function is when the number of codomains, the number of codomain is equal with the number of domain. So you can see it here. I have this. We have 1, 2, 3, 4, so 5, 6, 7, 8. So you can have something like this. Let me. So we have this. We have this. We have this. The number is equal to it. This is unto. This is unto or onto. This is onto. This is unto function. Unto function. Okay. Apart from this, we also have, as listed, we have a constant function. We have a constant function. So constant function is a kind of function in which all the domains have to produce one single image. All the domains have to produce one single image. Constant function is a type of function in which all the domain is able to produce one image. So using this arrow diagram, we have 1, 2, 3, 6, 8. Okay. So we have a B. So we have this. Okay. So all is able to produce one. You also have identity function. So identity function, in an identity function, is a kind of function. Identity function is a kind of function. Identity function is a type of function. In which a domain is able to produce an image or range that is itself alive. So it's able to produce itself. So So we can have an example of this picture where I have 1, 2, 3. We also have 1, 2, 3. So this produces this produces this produces this. So hope you know that if you have this kind of arrow diagram. Let me rub this out so that it will not confuse you. Hope you know that you have this kind of arrow diagram that I want to give now. You have 1, 2, 3. You have 1, 2, 3. So this to this, this to this, this to this is not identity function. Hope you know. Yes, it's not. It's when 1 is able to produce 1, 2 is able to produce 2, 3 is able to produce 3. That's when we say we have identity function. That's what we say we have identity function. So another name for one function is injective function. Another name for one function, injective function, injective function, injective function, injective function. So is another name for one function. So you can easily call the EUREKA on this phone number 07034593318 to give for physical interaction on your subjects or your courses to any level: physics, chemistry, biology, mathematics, computer science, statistics, and any other science subject.